We are going to talk about variables. What are they and what are their uses? Why should we learn them? You remember we introduced unknowns, also known as indeterminates. Indeterminates. So unknowns or indeterminates, they were things, objects that we immediately don't know their value. Their value is not determined. Therefore, they're called indeterminates or unknowns. Now, variables are a type of unknowns. So they're kind of unknowns, but variables, they don't have a fixed value. Their value varies, as the name suggests. So variables don't have a constant value. They can adapt different values. And all of these unknowns and variables, we can show them with a symbol, with a letter from alphabet. Usually we show them with X, Y, etc., or even Greek letters, alpha, beta, whatever. That's how we represent them. So variables are a type of unknowns. Their value is not immediately known to us. The difference is that variables, they vary. They don't have a constant value. Let's give an example. Imagine you want to measure the area of your room, and you have, for example, a rectangular room like this. So your room has a length, we show it with L, with the first letter, length L, and has a width. So how do we measure the area of your room? Is a rectangular, a length, and a width. So the area of your room, if we show it with A, represented with A, the first letter, is the length of your room multiplied by the width of your room. Sometimes instead of just this cross to represent multiplication, they show them with a dot, L dot W. Or sometimes even they don't say anything, they just say LW when there are two letters. So when you see nothing between them, between two letters, that means they're multiplied by each other. So area equals L times W, length times width. That's how you measure the area of your room. Now you see here, with this formula, A equals LW, not only you can measure the area of your own room, you can measure area of any rectangle, room or carpet or whatever. Any rectangle, you can measure its area. So these length, these widths, and the area, these are variables. They vary depending on what room, what rectangle you're measuring. So the length of your room could be something, the length of another room could be something else. So they're not fixed values, they're not constants, they change. That's why we call them variables. Now, why they're useful? They're useful because we can express them in these formulas, and we can measure any rectangle, the area of any rectangle. So we have a formula in front of us. So that's their use case. Or we can, in another example, we can measure let's go to another page. We can measure the perimeter of your room. So let's show it with P, and we know if, again, the room is a rectangular shape, so it has a length, it has a width. The perimeter of your room is that length of it all around. That line that goes all around it. So all of this green line is the perimeter of your room. So if it's a perfect rectangle, the length of it is the same, and these two lengths, they're the same, and these two widths are the same. So you just have to, for finding the perimeter, P equals L plus W plus W, right? Two lengths and two widths. We can write that in a shorter format by combining terms. Do you remember how to combine terms? P equals, let's combine terms. So I have two terms of the same nature, length, two length, one length plus another length, that's two lengths, 2L, 2 times L, plus width plus width, that's 2 widths. So 2L plus 2W gives you the perimeter. You can also simplify this and show it like 2, factor a 2 out of this, and say 2 parentheses L plus W. That's optional. You can show it in that way too. So that means these two gets multiplied by both L and W. Anyway, that's besides the point. So that's how you measure the perimeter of any rectangle. So you see here again, these are variables. These are all L, P, W, these are variables. But these twos, the twos are not variables. These are fixed values, right? These are constants. They're multiplied by L and by W. So these are not variables. P, L, W, they are variables. We can measure the perimeter of any rectangle with this formula. That's the usefulness of these variables, using variables. It's give a more kind of practical examples involving finance. Let's say your hourly income, you get paid hourly. And your hourly income, we call it X dollars. For every hour working, you get paid X dollars. The question is how much you earn in a week. Let's say you work full-time. By the way, full-time from 9 to 5. And what is your weekly income? How do you show that your weekly income? Okay, let's see how many hours, working hours, if you work full-time, how many hours you work in a week first. So 9 to 5, that is 8 hours of working in every day. Week has 7 days, but Saturday and Sundays is weekend, so you don't work. So there are 5 working days in a week. 5 days in a week. So every week you work, so every day you work 8 hours. Every week has 5 working days, so 8 times 5, that's 40 hours of work in a week if you work full-time. So now if you get paid X dollars per hour, we just need to, let's say your weekly income, let's show it with Y. Y equals 40 hours, that's constant, that doesn't change, it's not a variable, multiplied by X, your hourly income. So you see now we have a formula to calculate our weekly income. Y, our weekly income, equals 40 times X, your hourly income. Even you can make a table for yourself. You can say, okay, the first row is X, the second row is your weekly income. So this is your hourly income, dollars per hour. And this is, I'm going to put that in parentheses, dollars per hour. And this is weekly income, dollars per week. Just to know. So if you get paid, for example, $15 per hour, X is 15. What will be Y? Y will be, we can calculate this in our scratch paper. Y equals 40 times 15. So if you calculate that, that is like $600. Okay, so Y will be 600 if X is 15. So for any hourly income, you can calculate what will be your weekly income. For example, if you get paid higher, $30 per hour, your weekly income will be y equals 40 multiplied by 30, which will be 1,200. If you get paid $60 per hour, which is good, I wish you that one, your weekly income will be $2,400, right? So we can calculate. That's the use case of variables. We can just put different numbers into the formula and find out what will be the calculation. We can even visualize that. We can visualize our income. Look at here. Y equals 40x, we said. X, the hourly income. Y is the weekly income. Cool. We can visualize that. For example, we can say, okay, let's say this axis is the y-axis. This axis is the x-axis. So the x-axis is dollars per hour. The y-axis is dollars per week. Just so we remember. So I can show, for example, we can put different points on this axis. Let's say over here is 30 or 50 starting. In our table we start by 15. 15, 30, 60, and so on. You can have as many points as you want. And let's say for $15, we already calculated in our table. For $15 we gain 600. For $30 per hour we get 1,200 per week. For $60 per hour we get 2,400 per week, and so on. You can add as many. So now I know on this graph, here's where we stand. If we work 15 hours per hour, $15 per hour, here's the point, right? The point that corresponds to $15 per hour and $600 per week. Next, 30. So you put a perpendicular dotted line from 30 and also from 1,200 until they meet each other. So this point is your income. When you gain $30 per hour, you'll get $1,200 per week, and so on for 60 and 2,400. This is where you stand. And you can see this is like a straight line. It's a linear shape like this. You can connect them. So the higher you get paid per hour, the higher you get per week, obviously. So I wish you'll stand here. So that's the use case of variables. They're a type of unknowns. They're not fixed. Their value is flexible. They can change. And their use is that we can express formulas with them and do calculations, make tables, or even visualization. So in this case, we saw a linear behavior. When our hourly income increased, our weekly income correspondingly increased with it linearly, like a line going up. Let me know if you have any questions or comments.